Okay, guys, we're going to try some past paper questions on O levels mensuration here. Pehla question, it is from paper one, and this is taken from the year. Let me tell you what is the year. This is June '08. Okay, paper one. So the diagram shows a solid cuboid with base 10 cm by 6 cm. The height of the cuboid is x centimeter. Find an expression in terms of x for the total surface area of the cuboid. So there is no thinking required. You can simply recall that the total surface area is going to be that is uh, twice the length into the width plus twice the length into the height plus twice the width into the height. Okay, so this is going to be 2 times 60. Okay, this is 6 times 10 plus 2 times 10x and then plus 2 times 6x because this is x over here. Okay, so altogether the answer to this part is going to be 120 plus 20 plus 12, that is 32x. This much is the total surface area. And now it says the total surface area of the cuboid is 376. So you will keep all the surface area equal to 376. This is 120 plus 32x. That is going to be 376. So you solve this. It's a paper one question. This is going to be 256. Yes. Okay. And this will give you x equal to 8. So the value of the x is going to be 8. So it was a simple question on the surface area of a cuboid. Okay, guys, this is the paper two question. And this is from June of 4. Okay, paper two. And you can see that these formulas of the surface area of a sphere, the volume of a cone, and for the curved surface area of a cone, everything is given over here. Acha, let me just minimize this so that we can see that what is asking to from us. Okay. It says a drinking glass consists of a hollow cone attached to a solid hemispherical base as shown in the diagram. The hemisphere has a radius of 3 centimeter. Okay? The radius of the top of the cone is 4 centimeter and the height of the cone is 16 centimeter. Calculate the total surface area of the solid hemispherical base. You can see that he has highlighted this total. Hai. He has written this in bold. So that means the total surface area would mean this would include, if I do this A part, so that would include the curved surface area and plus the flat area. Okay, you have the flat base area there. The total surface area's formula is given as 4 pi r square. So the area, the curved surface area would be 2 pi r square, and then the flat area is going to be pi r square. First of all, you have to deal with this. So that is going to be 3 pi r square. Now you only have to put the value of radius into it. The radius is given as 3. So you can write this as 27 pi, and then you can use your calculators to give the answer. He's asking for the total surface area. So we'll have to write this correct to three significant figures. Okay? Then it says calculate the curved surface area of the outside of the cone. Now remember, we are given the formula for the surface area curve. You can see that curved surface area of cone is going to be pi RL. So when you find this curved surface area of the cone, so you have to recall, you have to remember, you must remember that there is a right angle from, if you draw it like this, so this is going to be a right angle triangle over here. Okay. So I can say that this length is 16 here. There is 4 here. And this is the slant height. This is the slant height of the cone that is, being used over here. In this pi RL, you have to use this L is the slant height. Okay. So using the Pythagoras theorem, you will find this slant height first. That is going to be L square equal to 4 square plus 16 square. Okay, so this L square is going to be 16 plus 256, that is 272. So I'm doing this mentally. Can you please tell me using your calculators that how much is this? and if this is really correct. Hmm? So since we have to find the curved surface area, so let's keep it in the exact form. For the curved surface area of this cone, that is going to be pi r l. This is going to be pi into 4 into the square root of 272. So now you can use your calculators and tell me what is this correct to three significant figures. Yeah, pi into 4 into the square root of 272. So what do you get?
Sir, 207.
207 correct to three significant figures. And tell me what is 27 pi as well?
84.8.
So it's
84.8.
84.8 centimeters
84.
square. So remember you to use the correct units here, okay? Acha, then we go into the C part. It says in the C part, the cone contains liquid to a depth of d centimeter, okay? Okay, it contains liquid to a depth of d centimeter. Giving your reasons, show that the radius of the surface of the liquid is quarter d centimeter. Acha, Vijay, this is a typical question that is used, uh, that is asked in a cone situation. It says it contains a liquid up to a depth of d. Okay, let me show you. Suppose you have the liquid here like this, up to a depth of d over here. Okay, so this depth of this is going to be, let me erase this and write it as this is T. Can you please note down the year of this paper, because then I have to mention this. This is from June '04. Okay, paper 2, question number 7. Acha. Now, uh, this one here. So he says, show that this radius of this radius of the top of this liquid is going to be quarter of d. This is the radius over here. Okay, the radius of this top. Acha, guys, from here you people have to use the concept of the similarity. When you have, I think we that will be our next topic. When you have two similar triangles, remember, like if these are two similar triangles, this is side. Let's say this is L1, this is the side L2, and this side is B1, and this side is B2. The whole bigger triangle has this side. Okay, so then this L1 over L2 is going to be B1 over B2. So similarly, you can let me say that if I call this is O here, this is A here, this is B over here, this is C over here, and this is D over here. You must be able to identify that the triangle OAB is similar to the triangle OCD. The ones who have done this, they should know that these two triangles are similar to each other. Okay, so the side OA over the side OC, OA over OC. Can I write this as D over 16? Because we have kept this OA as D and the whole OC is given as 16. Okay? And that is equal to this side AB over the side CD. And that is going to be R over 4. So this way, this is cancelled by this. So we have shown that your R is going to be quarter of D. So since it's an exam question, so here you will see that how one concept being mixed with another concept. So this was a part on the similarity, basically similar triangles. Okay. So then he says the cone is completely filled with liquid. Calculate the volume of the liquid. Okay, now it says the cone is completely filled with the liquid. So you only have to use the formula for the volume of a cone that is given to us. The volume is going to be 1 over 3 pi r square h. That is the volume of the cone. You can see it is written here. You can see this is the volume of the cone here, 1 over 3 base area. So base area is circular. So this is going to be 1 over 3 into pi. The radius of the cone is 4 and the height of the cone is 16. You can put this in your calculator and tell me what is this volume. That is 64. sorry, 256 pi over 3. That is your volume.
268.
Hmm?
268.1.
This is 268 centimeter cube. So this is the answer to the C part 2. Okay, the volume of the cone, C part 2. Acha, you have missed that pi here. Acha. And then in the last part, it says um, half of the volume of the liquid from the full cone is now poured out. Using the answers to part 1 and 2, find the depth of the liquid that remains in the cone. Okay, once again, bacho, it's a question from the similarity. You see, uh, this it says half of the cone, half of the liquid, it says half the volume of the liquid from the full cone is now poured out. Okay, half the volume is poured out. So we have to tell that how much is the depth of the depth in the water now. I mean depth of the liquid now. So can we say that the volume is now, what is half of 268?
134.
Okay, this is 134. You better not use the rounded value, but chale. Now the volume is 134. Okay, this is what we have. And now this is 1 over 3 pi r square into the depth. I'm not using h for, I'm using h for the this d for the h. That is 134. And we have to find the depth. Let me see. We have to find the depth. Okay. So we have to find the depth. Our whole equation should be in terms of d. Hmm? So can I say that using this relation over here, let me show you using this relation. He has given us a clue that using the answer to these two parts. So can I change the r with quarter of d? Hmm? This would become 1 over 3 pi,
1 over 16 d
pi,
square.
this is 1 over 16
D square.
d square into d, that is equal to 134. Okay, so this is going to be
1
uh,
over
pi d cube over 48, that is equal to 134. And this d cube is, this is clearly your algebra being used here, 48 over pi. Once you get this answer, then you take the cube root of this, put all of this in your calculator. 134 times 48 over pi. So how much is this depth?
45.2.
How can the depth be more than 16? You have to take the cube root, not the square root. So what is the depth, bacho? So this is going to be 12.7 centimeter. Okay. So this is how you had to do it. Okay, this one is a question from June of 5, paper 2, and it's a question number 7. It says the volume of a pyramid is this, and the volume of a sphere. So these two formulas are given. Morph made several different objects from modeling clay. He used 500 centimeter cube of clay for each object. Okay. So whatever he's making is using for every one of them 500 centimeter cube of clay. He made a square based cuboid of height 2 centimeter. Calculate the height of a side of the square. So we now know that this should be the total volume of that square based cuboid. ठीक है ना? So the square base cuboid of height 2 centimeter. So that means the base of the square should be, if this is the cuboid with us, so then this should be x over here and this should be x as well. And the height is 2. So this gives us the volume of this cuboid as 2x square. And that will be equal to 500 because he is using this 500 centimeter cube of clay. This gives us x square equal to 250. And then you use your calculator here. What is the square root of 250? Hmm? That is
8.8.
15.8. Yeah. So this is going to be 15.8 centimeter. That is the height of, sorry, the base of the side of the square. Okay, the side of the square of the base actually, that is 15.8. He made a pyramid with a base area of 150 centimeters square. Calculate. Now, this is really a good question. He's keeping giving you the simple, asking simple questions here. He made a pyramid with base area of 150. He's not telling us that what kind of the base is this. Now, I'm just going to make any, like suppose this is the base of that pyramid. Okay, so he has given us um, the base area. So we have the formula for the volume of a pyramid over. You can see this is the formula for the volume of a pyramid. So that is 1 over 3 times the base area, which is given to us as 150, into the height we have to find. That is equal to, again, that 500. Okay. So 350s are, the H is going to be 10. So this is calculated. This is found without even using a calculator. Then he says he made a sphere. Calculate the radius of the sphere. So again, the formula is given. So he's just testing your algebraic skills here. So 4 over 3 pi r cube, that is equal to 500. So this pi r cube is going to be 500 times 3 over 4. This r cube is 500 into 3 over 4 pi. And then you take its cube root. Okay, cube root of this 1500 over 4 pi. That will be the radius. So find this radius.
4.92.
You find the cube, that is 4.92.
Yes, sir.
Yeah, this is 4.92. So this radius is going to be 4.92 centimeter. So guys, you see there was no thinking required. He gave us the formulas and then he gave us a volume and he just going to test that how do you manipulate these algebraic equations here. So this up to this was an easier question. Then he says he wrapped the clay around a curved surface area of a hollow cylinder. Oh yes, this cylinder will always be there in your paper too. Cylinder of height 6 centimeter. The thickness of the clay was 1.5 centimeter. Calculate the radius of the hollow cylinder. Okay, so let me take two different colors now. Let's assume that this hollow cylinder's radius is r. Okay. Then what would be the radius of this outer cylinder here? If this is r, what would be this radius, Bacho? Hmm?
1.5 plus R.
Exactly. This is going to be
1.5
r.
plus R.
Yes, very good. R plus 1.5. Can I say now that the outer cylinder's volume minus the hollow cylinder's volume, that will be equal to this 500 centimeter cube, है ना? है ना बच्चों? So the outer cylinder's volume is going to be pi. Let me use the yellow color here. Okay, this is going to be pi. Its radius is r plus 1.5 square and the height is 6. Okay, minus pi r square into 6, that is going to be equal to 500. Okay, the outer cylinder minus the inner cylinder. Acha, if you want, you can take your pi 6 pi common from here. This is 6 pi into, this is your r plus 1.5 square minus r square, that is equal to 500. है ना? This 6 pi is here, this 6 pi is here. I have taken that common. This is 6, this 6. Okay, this 6. Okay, now I'm going to expand the square over here. This is going to be r square, a square plus 2ab, that is 3r plus b square, that is 2.25 minus r square, that is equal to 500 over 6 pi. But so this is your simple algebra. I have applied here a plus b whole square. So a plus b whole square is a square plus 2ab plus b square. We have done many questions on it. Okay. So this is your 3r, that is equal to, I'm not going to use calculator, Abhi. Can I write this as 250 over 3 pi? है ना? just cancel with the 2, minus 2.25, and finally your radius is 1 over 3. And now you people have to use your calculator. This is how the smart people solve these complicated equations. Try to use the calculator at the very end, otherwise you will keep on rounding off the figures and you will go far away from the actual answer. Now write all of this in your calculator and tell me what is this radius. Hurry up.
8.09.
8.8.09.
09.
Okay, this is 8. Let me ask from some other people if they have. This is 8.09. That is the right answer, 8.09 centimeter. Okay. Okay, we are still left with some of this. Look at this, the last part, the E part. Um, he says, let me clear some of the area from here. He's saying that, okay, he's telling us that he made a cone. Then he cut through the cone parallel to its base to obtain a small cone and a frustrum. Okay. Now this lower part is a frustrum and the upper part is a cone. The height of the small cone was 2/5 of the height of the full cone. Use a property of the volume of similar objects. Now, you might not have done this, but let me tell you again. When you have two similar solids, the V1, this is a very famous formula, V1 over V2, that is going to be L1 over L2 whole
All
cube. Okay, there is a cube on it. Like you have the formula for the A1 over A2. When you have two similar shapes, the ratio between their areas is going to be L1 over L2 whole square. These are very famous formulas. Okay. Now, he says use a property of the volume of similar objects to calculate the volume of the clay in the small cone. Acha. Now, bacha, we know that if I just draw a line through this, let me draw the line here. Okay. So if I draw this line here, so he's saying that the height of the small cone was 2/5 of the height of the full cone. So can I say that if this much is 2, then all of this height is going to be 5, है ना? Because saying this height is 2/5 of this, है ना? So can we say that the volume of the small cone, the volume of the small cone over the volume of the bigger cone that we know that is 500 is going to be equal to 2 over 5 cube? Yes, that is the ratio between their corresponding sides. ठीक है बच्चों? So this will give you the volume of this smaller cone here. So that is going to be 8 over 1 to 5 times 500. And you use your calculators, or you can simply cancel it out with 4, I think. And that is going to be 32 centimeter cube. So that is how you had to do that. Whenever, like, he's himself telling us that use the property of volumes of similar objects. So we shall be doing this inshallah very soon, the ratio between the sides and the areas and the volumes of the similar shapes or the similar solids. Okay, so that is it from the day. But so I have tried to solve some of the questions from past papers to make you clearer, make this concept of the mensuration clearer to you. Okay.